Hello everyone, my name is Javier Morin and this is the video presentation for the final project of the course TCN 4211 Telecom Networks. The title for this project is Types of Networks and the team is formed by 4 students. Javier Morin speaking, Davidson Bourdeau, Antonio Marchera, and Jeff Ciudad. We divided the topics in 2 possibilities, wired or wireless. Then we focused on twisted pairs and fiber optics for wired networks and Wi-Fi and satellite for wireless networks. Transmission and reception of data are crucial subjects of the modern world. They involve hardware, software, media, and security. On many occasions, individuals have to choose among different types of networks by relating their own needs and budget. Sometimes there's a unique choice, but other times not. The research of this paper focuses on describing the characteristics of the different networks and their uses. Hopefully, the information within will help individuals make their best choice for either home and business. Following, student Jeff Ciudad will continue with wired networks on twisted pairs.
Hello, my name is Jeff Ciudad, and I'm going to show you what wired networks are. So what are wired networks? A wired network is when multiple devices such as computers and printers are able to work together to make one central hub full of communication and data. With wired networks, you can be able to transfer all different types of data between multiple PCs. First, we're going to talk about unshielded twisted pairs. So, an unshielded twisted pair, or UTP, is a type of wiring that allows cables to function without any electromagnetic interference. An unshielded twisted pair consists of two wires with two different signals in each end. An unshielded twisted pair is also known for being able to create networks, and you could also use them to make video applications with them as well. One example of how you can use a UTP is you could use it through the use of a Cat5e cable. Cat5e cables are what allow unshielded twisted pairs to properly run. Not only that, but an unshielded twisted pair cable depends on the cancellation that is caused by electromagnetic interference as well as radio frequency interference. An unshielded twisted pair could have up to 4 twisted pairs, and they are covered by a plastic cover. Unshielded twisted pairs also have a great bandwidth, which helps for transferring data and making it responsive and fast. UTPs are separated into 5 categories. First, you have the Cat3, which is used for phone lines. Then you have the Cat4, which is used for token ring networks. Then you have the Cat5, which contains 2 twisted pairs used in token ring networks. It could support up to 16 megabits per second, and it is commonly used in Ethernet-based LANs. Then we have the Cat5e, which contains 4 twisted pairs. It could support up to 1 gigabyte per second, and it's used in Ethernet-based LANs as well. Lastly, we have the Cat6, contains 4 tight twisted pairs, supports 1 gigabyte per second for 100 meters, and 10 gigabytes per second for 50 meters. Next, we're going to talk about shielded twisted pairs, or STPs. A shielded twisted pair is a copper wiring. It requires a shield to protect the wires that make the STP. The pairs are covered in a metal covering, and they are commonly used for Ethernet networks. and they are known for decreasing the amount of noise from pair-to-pair coupling and crosstalk. The only flaw with shielded twisted pairs is that they tend to be more expensive than unshielded twisted pairs. A shielded twisted pair cable can have many features. They can support speeds between 10 megabits per second to 100 megabits per second. It has a moderate price. They have large connectors, and their length can be up to 100 meters.
Hello, my name is Davidson Bodo, printer ID 6196924. Has anyone ever heard about wired network? Well, wired network is one of the most important networks. That's why in this presentation, I'm going to talk about optical fiber cable, which is one of the most important cables using in a wired network. First of all, what is optical fiber? It is a type of media that transmits data in form of light, and it is one of the most important media in the network infrastructure today. So, with the high demand for faster data transmissions, internet connection, phone calls, and interconnection between networks, very good quality of media are required. That is why fiber cable will be one of the topics of our presentation. So from the following slide, we will see the structure, types, advantages and disadvantages, and the different applications of the fiber. From this picture, we can see a fiber cable. This is the real structure of the fiber cable. It has an inner core where the data is being transferred in form of light. It has the cladding, which has a smaller index of refraction, which prevent the light from leaving the core. And then we have the cladding, strength member, and outer jacket. They are all protect the cable. So there are two type of fiber cable. We have multi-mode fiber and single mode fiber. The multi-mode fiber has a smaller, has a bigger core diameter than the single mode fiber. And then the multi-mode fiber can travel smaller distance the than the single mode fiber because the light travel inside of its core in zigzag way. However, in a single mode fiber, the light travel in a straight line through its core. That's why you can travel when you want to transmit data to a long distance communication. It is better to use a single mode fiber. Why optical fiber cable? What are the advantages and disadvantages? So it provides fast data transmission has advantages, and it allows long range transmission with almost no losses, and it has a lot of bandwidth capacity. So that's when it can handle a lot of data. And then some of these disadvantages are it is very expensive to maintain. So you need certified technician. You gotta pay all those technicians, and you also need high quality of equipment to maintain the cable when you need to do maintenance on the cable. And what are the applications of fiber cable? For example, in the telecommunication network, it is specially used in cellular network for coverage purposes. For example, when a mobile switching center want to connect physically with a base station controller, so it is better to use a single mode fiber to do this link. It is also using almost all computer networks, either in long or short distance. So for example, if we want to connect to local area networks physically, so the best way to do that is using a single mode fiber. Based on the distance, you can use a multi-mode fiber too, because you're gonna have a lot of good connection and it's not gonna be easy to lose a lot of data. So thank you. And then we are going to be proceed and then by seeing the another type of network, which is wireless network.
Good evening, my name is Antonio Marchetta. Today I'll be going over wireless networks, specifically for Wi-Fi. So as you may know, Wi-Fi is one of the most highly selected when it comes to telecommunication networks, due to it being a network that is very reliable in its speed, and it's also used without any wired connections, which is a plus when we move forward to a future where wired connections are slowly but surely becoming obsolete. So let's see how that works. So essentially, how Wi-Fi works is that we first get a connection from an internet service provider. That connection is then transferred over with a DSL cable. It feeds off to a modem. The signal then gets transmitted into radio signals, and it allows for devices nearby to connect, thus providing them with internet access. As you can see here, the radio signals are transmitted to devices such as laptops, computers, tablets, and PCs. And essentially, for these devices to be able to connect, they use a wireless adapter to translate the data into a radio signal and transmit that signal using an antenna. So those radio waves, they emanate upwards from the antenna and they receive the information through the wireless router. Now, that wireless router then converts the radio waves back into data and then sends that data to the internet using a physical connection. So to get the data from the internet to you, you just reverse the process from the laptop to the tablet to the phone. That's essentially how that works. And so as we move forward, you'll see that there's 5 different types of Wi-Fis. We first have 802.11a, 802.11b, 802.11g, 802.11n, and 802.11ac. Each of these standards, they come with various pros and cons related to data speed, signal interference from outside sources, and cost. And obviously cost is a factor because different hardware is needed for different standards, though newer versions are made to be backwards compatible with older versions. Now, just like many things, Wi-Fi also has its vulnerabilities, and being one of the biggest vulnerabilities for Wi-Fi is that since the company designs them to be simple and give them the ability to operate with multiple devices, security becomes its biggest flaw, since they make it difficult for customers to have their network protected. Therefore, they are more susceptible to being hacked. One of the steps that you can take to avoid this is, number 1, change the system ID. Number 2, disable identifier broadcasting. Number 3, enable encryption. 4, restrict unnecessary traffic. 5, change the default administrator password. And 6, patch and protect your device. Now, when it comes to speed, I would say Wi-Fi is very reliable when it comes to speed. It works with 2 different types of frequencies, 2.4 gigahertz and 5 gigahertz. These frequencies are much higher than the frequencies used for cellular transmission. Higher frequency means that signals can carry more data. However, all forms of wireless communication represent a trade-off between power consumption, range, and bandwidth. So in exchange for high data rates, Wi-Fi consumes a lot of power and does not have a lot of range. So you can see here 2.4 gigahertz is the most highly used by customers. It has a larger coverage, slower speeds, and 5 gigahertz has lower coverage and higher speeds. So it all depends on what you want to do. You can select what frequency you like. Now, when it comes to reliability, For your average Wi-Fi router, ranges are much, much shorter and depend on a number of factors. Range can depend on the antenna reflection and refraction and radio power output. So with that being said, Wi-Fi networks, their signals can become damaged due to the antenna's reflection and refraction and the outputs. Now, a range of about 100 feet is common, so it might be a physical barrier that could be stopping it. Now, usually radio waves, they pass through most kinds of materials, but they can be blocked or absorbed by materials that conduct electricity. Water also conducts electricity, meaning that our bodies can actually interfere with Wi-Fi. But don't be alarmed because radio waves don't cause cellular damage, so at least that's something that we don't have to worry about. Other than that, Wi-Fi does give the ability to the user for them to transfer data efficiently and with acceptable speeds while maintaining low cost compared to wired networks. Now that we've gotten over Wi-Fi, let's go ahead and switch over to satellites, which Javier will be taking over. Thank you very much.
My name is Javier Morin, and I will be discussing satellites as the last topic for this project within wireless networks. Following, I will discuss types of satellite systems that exist. Satellites are classified depending on their orbit. The three most popular orbits for communication satellites are low Earth orbit, medium Earth orbit, and geostationary Earth orbit. Low Earth orbit satellites are at an altitude of approximately 780 kilometers, and each passes a given user in only a few minutes. The principal advantage of this kind of satellites is the shorter range that the radio signal has to traverse, requiring less power and minimizing propagation delay. Their short orbital period produces relatively brief durations when a given satellite can serve a particular user. Medium Earth orbit satellites are around 10,000 kilometers, and these kinds of satellites have a much longer period and thus tends to hang over a given region on the Earth for a few hours. Lastly, geostationary Earth orbit revolves around the Earth in the plane of the equator once in 24 hours, maintaining precise synchronization with the Earth's rotation. In this slide, you can see an image representing the three types of satellites and their orbits. Notice the distance between the three. Following vulnerabilities. Vulnerabilities are a big deal with satellite signals. They differ between systems, but overall, satellite communication systems are vulnerable to hacking. If an effective attack is carried, the satellite may be maliciously controlled, disrupted, and damaged. A common way to threaten data and related connected devices is by hacking the VSAT, the Very Small Aperture Terminal, which we will talk in the next slide. Spoofing. Some satellite organizations miss ciphering and encrypting the uplink tracking, which makes the satellite vulnerable to spoofing attacks. Spoofing attacks provokes the receiver to accept validation of someone sending false signals. Lastly, as the easiest way of hacking a satellite signal, it is found what is called jamming. The radio frequency gets disrupted by transmitting other signals, so the original will not reach its destination. This is really worrying for users using satellite signals. This image is an example of a very small aperture terminal. The purpose of this device is to transmit and receive satellite transmissions. It comprises a dish antenna, a transceiver, and a satellite router. Some of these devices can be received only and may not include a transmitter. This is important relating to vulnerabilities. Now in this slide, following there is a comparison on internet speeds and estimated costs through different media. Here in the table you can see how satellite stays low um, at each subject: affordability, speed, reliability, but availability is very high compared to all other medias. And this is very important when there's limited access for DSL fiber and cable in, let's say, rural zones that only satellite signal can get there. And this table shows more detailed data on download speeds and upload speeds with the megabits per second. Here you can see how satellite stays low compared to all other media. And this is the price per month in dollars. And I see how satellite is just not as expensive as I thought before doing the research. It stays like pretty much like cable and fiber. Satellite is available virtually everywhere. It is more widely available than cable internet. But that doesn't answer which internet service is best for your business. Unfortunately, the answer isn't as simple as picking a winner. Each type has its own benefits, flaws, and quirks. There is no unique and simple answer to which internet or TV service is best for people's needs. Each type has its own characteristics, quirks, flaws, and benefits. Following this slide, we talk about reliability. Availability is the term that denotes the reliability of satellite signals, which is the percentage of time that a communication link can provide service. Link reliabilities of 99.9% are just the usual trend for fixed satellite services, with an adequate outage of 9 hours a year. What this really represents is a few minutes of segmented outage spread mainly during months of rain. There are some events that affirm the remarkable reliability and benefits of satellite communication. The following is an example in the area of emergency response when a devastating earthquake hit Mexico City back in 1985, and the available satellite by then maintained reliable TV transmission in the country, being that all terrestrial lines were out. Similarly, in Sumatra Island, satellites provided disaster relief by maintaining communications after a 2004 tsunami. Here in this image, I'm comparing the reliability between cables and satellite signals. I mark here that satellite signals are extremely higher in reliability. When compared to cable systems, the reliability of satellite is extremely higher. When outages on terrestrial systems occur, they can take up to several hours or even days. There is indeed another way to this downfall, and it is to provide diverse routes. But this is really expensive and reachable of wealthy organizations. And we all can relate in our homes when internet goes out and you have to call your company Comcast or AT&T. You have to set up a technician to come to take a look at your equipment, your outside premises. Um, with satellite signals, this happens not very often that you lose signal. So they are pretty reliable. In this slide, I would like to talk about security. There are some methods of prevention that organizations should use to stop cyber criminals. One of the most important methods in securing communication links is encrypting the data transmitted through the VSAT device link. A way of doing this is by splitting the data when it enters the VSAT terminal and isolating the traffic. Other ways are using receding interference, waveforms, cancellation, and changing bandwidth. As the last topic to talk in security subject is penetration tests. Carrying a penetration test is advisable to model threats and identifying boundaries where data flow can be weakened. This is done by professionals called white hackers that understand the threats a system could be exposed and their consequent risks. So satellite companies could hire these white hackers, also called ethical hackers, to try and penetrate the satellite signal and check for threats. And then, well, focus on applying the encryptions, the interference waveforms, cancellation, as providing solutions for some threats that they can find during their penetration test. This slide kind of answers how widely is satellite used. Well, satellite systems are essential to many governments and businesses throughout the world and represent a $100 billion investment today. Almost all television signals travel by satellite today. The public telephone system has greatly improved thanks to the satellite development, bringing nations more closely. Because of the communication applications that they facilitate, satellites are used extensively, providing wide area coverage, country, continent, or globe. Wide bandwidth independence from terrestrial infrastructure, rapid installation of ground networks, low cost per added site, uniform service characteristics, and total service for a single provider. So, satellite signals are available almost everywhere. And they are slow, yes, but they provide reliability all the time. Slower speeds due to far traveling signal shouldn't be a stop for using satellite signal. Satellites were the last topic of our project. Now, in this slide, we would like to offer a special thanks to Professor Yudu in accepting and supporting the proposal for this project as an special acknowledgement ending our research project for this course.